My dear students, I am very happy to see you today. Today, we will get the important lesson. Sure, we must say the important. Do you know why? Because it's our target to get a full mark. So, today we will start for chemical analysis. This is about Unit 2. Are you ready to understand it? Sure. The lesson will be, what about to look at this? This apparatus can be used in titration. Concentrate. Titration, it means I get acid, as you see, 25 centimeter cube of HCl, and I try to know for this. This is unknown concentration. I don't know its concentration, and I want to know what about them. So I get phenolphthalein as indicator. This is colorless. Added to what? Added to this acid. Sodium hydroxide here is used, yes, by 0.10. I add for the purette. Sodium hydroxide starting with added to 0 number. Why? To make a titration. NaOH follows into the flask, and I try to add it to unknown concentration HCl. You see, I add drop one after one, and I make a checking. Pink here start to appear, so it goes after wrapping to colorless. Shake and more the color disappear. At the beginning, pink. After time, disappear. I say, why all of them? Don't forget, I have hydrochloric acid. This is used, and also I have NaOH. This is base. You have acid and base. Yes, acid and base. By shaking from time to time, they are neutralized to arrive to the ending point of this reaction. You see, I add drop one after one. You can see here titration depending on the number of the moles for both acid and base. Pink doesn't disappear now. You see, add it. Oh, after shaking again, it disappeared. I add more and more, a lot of time to arrive to my aim. My aim here, ending point. I stay till the pink color doesn't disappear. Good. Now I have an ending point. Where is the color? The color here stay. NaOH is used to neutralize the acid. You see, this neutralization very important, by 25 centimeter cube of HCl by 25.4 centimeter of NaOH. All of them arrive to ending point. I can repeat this experiment a lot of time to arrive my titration, my ending point that tell me the result. It's good, I'm fine. Let's complete our talking about our fun lesson for chemical analysis. So, I can say here chemical calculation can be obtained from the analysis because it depending on each part. As a beginning, I look at this table. I have radicals, its symbols, and its valency. Hydroxide, OH negative, valency 1. The other one, nitrate, NO3, valency 1, also negative 1. Nitrite, NO2, negative. What is the valency? The valency is a 1. You have bicarbonate, HCO3, negative. It means the valency 1. All the first group, the radical with the valency 1. Monovalent radicals. The other one, when I tell you about good sulfate, HSO4, also its valency monovalent, it's 1. For the other, ammonium NH4, the only positive which has valency 1, monovalent radical. This is the first type of the radicals. Second one, for the radicals, you say divalent carbonate, CO3, negative 2, valency 2, divalent. Oh, radical can be mono, can be di. You have a sulfate, SO4, negative 2. What is the valency? Valency 2. Sulfite, SO3, good, negative 2, valency 2. All of this table 2, it means divalent. Thiosulfate, S2O3, negative 2. All of these radicals, yes, all of these radicals, it's easy. You can say dichromate, valency 2, Cr2O7, negative 2. It means the special radical for divalent. You have phosphate, PO4, negative 3, valency 2. Only no, we have common acids. Common acids here, it means HCl, hydrochloric acid. H2SO4, the other type of the acid, it's sulfuric acid. HNO3, nitric acid. You have H3PO4, phosphoric acid. And the other, H2CO3, carbonic acid. This common acid, we use it for the answering the problem that this unit depend. Look at this. When I fly to the common alkali, the same. You use different one. Sodium hydroxide, NaOH. It has a special name, caustic soda. When you say caustic soda, sodium hydroxide, NaOH. KOH, potassium hydroxide, caustic potash. You have a two, caustic soda, caustic potash, sodium hydroxide, potassium hydroxide. Calcium hydroxide, CaOH by 2, very important piece. Magnesium hydroxide, MgOH by 2. So you must know any hydroxide must contain what? Contain OH. Common acid, common bases, and different radicals help me to arrive to this unit. Can you make a chemical formula of the molecular element? Sure, it's easy. How can you do? Look, diatomic molecule of the element in the chemical reaction. O2, H2, N2, F2, Cl2, Br2, I2. Why I say 2, 2, 2? This 2, it means diatomic. It's impossible to write this element O, H, N. No, it's wrong. Must add what? 2, diatomic. Also, the molar mass. Can you find the molar mass? Yes, I can. It's a molecular mass of substance expressed in what? Expressed in grams. When I say you have any compound, change it to molar mass, I can do that. Let's see. Find the molar mass of these molecules. Different molecules, millions of the molecules. Look, I have the first example. The first one, molar mass of oxygen. Oh, he say oxygen or oxygen atom. Just oxygen, it means molecules. O equal what? O equal 16. Another one, molar mass of O2, because they say oxygen, oxygen gas, oxygen molecule, O2, or only just atom. I can say for this case 16 pi, good, 2. What is the result? It will be 32 grams. What I have? Molar mass. Change this gas into gram. Another one, the molar mass of sodium. Sodium monatomic. What its mass? Molar, yes, this mass number, 23. Molar mass, yes, also 23. Why? Because just monatomic. 1 by 23 equal 23 grams. Good to arrive to molar mass. Molar mass for diatomic. Molar mass for monatomic. by 2 or by 1. Molar mass of the carbon dioxide. Carbon 12, oxygen 16. I have a compound. It's not big compound, but it's easy. Has more than atom. So I can say it as molar mass of CO2. Number 1. I have what? 1 by 12. 12, this is for carbon. 1 mole of the carbon. O2, 2 by 16. 2 for 2 of oxygen. 16, the molar mass of oxygen. The result now will be 44 grams. It's easy and to learn all of these different molar masses. Mass and molar mass. Mass of 1 mole. Look at this triangle. What this? Molar mass. Molar mass, yes, I can say molar mass by the number of moles equal what? Should we say the mass? You see, mass equal number of the mole by molar what? By molar mass. It's easy and important for different problems. Catch another problem. These problems have many examples. As you say, calculate the mass of 0.5 mole of bromine. Bromine, when I say bromine, it's easy. Br equal what? It's atomic mass 80. Sure, I can say find solution easily. What do I do now? Look, mass of 1 mole of bromine. Oh, Br2? Yes, because bromine diatomic, don't forget. As oxygen, nitrogen, hydrogen, fluorine, chlorine, all of them diatomic. So, bromine diatomic. What you have now? I can say 2 by 80 equal what? Equal 160 grams. At the same time, the mass equal, for this case, number of mole by its mass of 1 mole equal what? Equal 0.5 by what? 160 equal 80 grams. You learn, find step by step. Number 1, find the molar mass. Number 2, I use the triangle that helped me to find the mass. It's easy. What about when I say other method for the answer? 1 mole for molar mass bromine. Look, 1 mole 2 by 80 equal what? Equal 160. So H1 mole 160. I can say 0.5 mole equal what? X grams. You see, I make it as an equation for the two sides. 1 mole, molar mass. Make cross multiplication, I can mass of bromine equal what? Equal X. X equal what? Cross multiplication. 0.5 by 160 over 1 equal 80 grams. The same answer, but the other method to answer this type of problem. So any problem can be answered by different method. Why not? You must concentrate and try to find the suitable for you. Don't forget that. Look at this example. He say calculate the mass of 2 moles of caustic soda. Caustic soda, yes, we learned it before. NaOH, Na23O16, H equal 1. It's easy. Which method you need? I have a different method for solution. Mass of 1 mole caustic soda NaOH equal, good, 23 plus 16 plus 1 equal 40 grams. Good. Caustic soda, 40 grams. What else I can say? Or 1 mole, 2 molar mass. 1 mole, 2, good, 40 grams. 23 plus 16 plus 1. So 2 moles equal what? X grams. What I do? Nothing. Cross multiplication. I can find as mass of caustic soda for this case. X equal. Good. 2 by 40 over 1 equal what? Equal 80 grams. You see, darling, it's easy to catch all of this of problem. Easy. Steps. Just steps. I make many steps to get full mark. All right? Don't find the final result quickly. No. When I ask you how many mole, oh, in what? 64 grams of the oxygen. Don't forget, O equal what? O equal 16. Catch the answer? Easy. 1 mole of oxygen. The mass of 1 mole equal what? 2 by 16 equal 32 grams. Now, I can say the number of the moles for this case equal what? Equal, look, mass over molar mass from the triangle which you studied before. Number of mole equal mass over molar mass. So, I can say for this case, number of the mole equal mass 64. Molar mass 32. The result can be 2. Or the other method for the answer can say 1 mole to molar mass of oxygen. 1 mole to 2 by 16. This is the mass for oxygen equal 32 grams. Then I can find X mole equal 64. What I do? Nothing. Cross multiplication. Can you find the X? Yes. Number of mole X equal what? 1 by 64 divided 32 equal 1, no, equal 2 grams. It's easy. The answer must be unequal. Do you understand this? Different method, the same answer. Look, darling, when I say how many mole in 27.8 grams of lead 2 chloride, Pb 207 Cl 35.5. The same solution here can be as the mass of 1 mole BbCl2. It means lead chloride. Can I find it? Yes, it's easy. 207 plus 2 by 35.5 equal what, my dear? Equal 278 grams. This is for what? This is especially for barium chloride. Look for the other number of the moles here equal. Good. I can say mass over molar mass from the triangle which you studied at the beginning. Look for this. I can say the number of the moles here equal. Good, my dear. 27.8 divided 278. The result will be 0.1 mole. You think it's difficult to answer this? I have another method? Sure, I have a different method for the answer. I can say here or 1 mole to molar mass. 1 mole to 207 plus 2 by 35.5. Now, what you do? I don't hear cross multiplication. Cross multiplication here to find the x to 27.8. What you have now, I can say number of moles equal. Look for the number 1 by 27.8 over 278. The same result sure will be 0.1 what? Mole. Don't forget to write the unit. Any type for the same questions, same answer. You understand thing? I think it's very easy. What about to get the other problem when I say how many molecules? Oh, it's differ. How many molecules and the atom in 0.5 mole of hydrogen? This question is a differ. Why it's differ? Because I say molecule or atom. Molecule or atom here I fly to Avogadro's number. Number of the molecules for this case equal what? equal number of the moles by, good, 6.02 by 10 power 23. Do you know what this means? It's Avogadro's number. Yes, why we use it? Because I said here molecules. I said atoms. These words help me to find Avogadro's number. So I can say 0.5 by 6.02 by 10 power 23 equal, good my dear, 3.01 by 10 power 23. I think it's easy to find number of molecules. What about this question? How many moles, molecules, atoms in what? C10H6O3 are found in 87 grams. Oh, what this? I have a compound. This compound is very important. I don't know it, but it's okay. I know its formula. I need molecule, I need atom, I need mole. Many things. Steps, it's very easy. C equal what? C equal 12. H equal 1. O equal 16. You remember this number? This number back to what? The mass number of atoms. So the solution starts as 1 mole to 10 by 12 plus 6 by 1 plus 3 by 16. What this mean? The molar mass of this compound equal 174 grams to 6.02 by 10 power 23 molecules. This is the other side for this problem. I can find 87. Now, my dear, I say X mole equal what? To 87. So I have Y molecules. What I do for these cases, I can say X equal, put the numbers now, 1 by 87 over 174 equal what? Equal 0.5 mole. Now you have a Y. Y, it means the number of the molecules can be as, look at this, 87 by 6.02 by 10 power 23. Do you know what this means? It means Avogadro's number, because I need molecules. All of them over 174. Then you have an answer, yeah, 3.01 by 10 power 23 molecules. After that, I can say for these cases the number of the atoms. What about the number of the atoms here? As a molecules, I can say as number of molecule, yeah, because both depending on Avogadro's number. What is the result? I can say number of the molecule by automatically. So I can say 3.01 by 10 power 23. There is a difference? No, because both are equal. After that, I can say by 19, all of them will be 5.719 by 10 power 24. Volume of the gas and molar mass. Volume here, it's back also to Avogadro's number. Molar volume or molecular volume. We say gram molecular volume. Sure, what I do, it's a volume occupied by 1 mole for any gas at a standard temperature. Do you think it's a constant? Sure, it's a constant because it's back to Avogadro. When I say at STP, stable temperature and the pressure, STP, stable temperature and pressure, equal what? Constant, equal what? 22.4 liter. You see? Good. Now, what about this? STP here for the example number 1. When I ask you about 1 mole of the oxygen gas O2 has molar mass equal 32 grams, 2 by 16. You say, occupying what? 22.4. Why? Because just 1 mole of oxygen. Any mole of anything, constant number 22.4. not more. Now, containing the number of the molecules equal Avogadro's number. Yes, I know, 6.02 by what? By 10 power 23. We arrived to the end of the lesson. Do you think you understand it? I think so. Study it well to get a full mark. I'm waiting you to tell me your opinion about the lesson. My dear, see you soon. Thank you and goodbye.